Okay.
Did you have a pencil?
Yeah. Right here. Okay. So, you know this as like x is less, like we'll use x. You know this as being like x is less than or equal to 4, right? It could be 4 or less. So, you are used to writing it like this. And that's right. Okay, in Algebra 2, we add a little bit of the way that we notate this. We add this in. We add the curly braces, and then we define the variable. Okay, so this is saying x such that x is less than or equal to 4. Why less? Well, because that's where it's pointing, right? It's pointing to all the numbers that are left there, so it's less than. This one is an open circle, so you know that as greater than 4. Well, it's not greater than because it's open. It's greater than because the arrow's pointing to the right. Okay? But there's no bar underneath because it's open. That's what you learn middle school. Algebra 2, I say yes, but we're going to add in x such that x is greater than 4. Okay? Okay, this one, the variable, the shading, the blue stuff, if you will, is in between two numbers, right? So it's in between -1 and 3, so x is in the middle there. We include -1, but we don't include 3. So this is saying x is in between -1 and 3. X is greater than -1. See, so in the inequality symbols, it always points to the smaller number. So it's saying -1 is smaller than x, and x is smaller than 3. Okay? This one is a little different. X is not in between, it's on the outsides, right? So this one would be saying set of all x such that x is less than or equal to -1, or x is greater than 3. I can't write this one like this. I can't put x in the middle because it's literally not in the middle, it's on the outsides. Okay? This one is similar to the previous one, right? Except it is going to be x such that, so x is in between -1 and 3 this time. But it does not include -1, so no equal to, and it does include 3, so equal to. And then this one would be the set of all x such that x is less than -1, or x is greater than or equal to 3. And then this one, set of all x such that, I know, it gets annoying writing this part over and over again, doesn't it? Let's see. X is less than or equal to 5, or x is greater than or equal to 10. So this is set builder notation. Also in Algebra 2, we learn interval notation. That's the one with the brackets and the parentheses and the infinities. This is the one I really want you to clue into because I think this is going to be the one that you like. Okay? So in intervals, we talk about where it begins, where it ends. Okay? So notice the beginning of my number line is an arrow. What do arrows mean again? Infinities. Can we ever reach infinity? No. So an interval, this would be parentheses, negative infinity. Why is it negative infinity? Because it's the first one. That's a terrible infinity. All the way up to, where does our solutions end? 4. Do we include 4? Yeah. So this would be a bracket. Okay? All right, if I do this one, notice for interval notation, you don't need curly braces. Curly braces is only if we're going to use set notation. This one, the beginning of our interval is 4, but we don't include it because it's an open circle. So this one would be parentheses 4 to infinity. Positive infinity because positive infinity goes to the right. Okay? All right, what about this one? This one begins at -1, but ends at 3. But we're including -1, but not 3. So this one would get bracket -1 to 3 Bracket or parentheses to end it? Parentheses. Okay, now this one has 2 intervals. Okay, so here's how you do the 2 intervals, and this is the one that we're going to use this today, okay? There's 2 intervals, right? So first I start with the first one. That's an arrow. We know that means negative infinity because it's going to the left. Up to -1. And that gets a bracket because we're including it, right? Okay, now there's a whole other interval. So whenever I have 2 intervals, you have to draw a U in between them. That means union, okay? If I'm going to speak the language of intervals with infinities and brackets, then I have to speak the language, I have to include that U. And then the second interval begins with 3 parentheses up to infinity parentheses. So you have to have a U if you're ever joining them. So when you see that in your Delta Math homework, because your Delta Math homework is going to have the U, all you have to know is that that means there's 2 chunks. Okay? All right, this one is in between, so this one would be parentheses, -1 to 3, bracket. Closed circle gets a bracket, open circle, parentheses. Okay, let's think about this one. I have 2 of these. First one goes from -infinity up to -1. I don't include that, so parentheses. What do I have to put in between my 2 intervals? What goes here? A U. Bracket 3 to infinity. And then this one, similar. This one would be -infinity up to 5, bracket, because it's a closed circle. I got another one, so I union 10 to infinity. Okay? So what we're doing today is a lot like what we did yesterday, except they're going to be inequalities, and we're going to have a number line. And we are going to give our answer either like this, in interval notation, or set builder. In notes, I'm going to give you both. Okay? But when you give it back to me, you pick which one you like. Okay? All right, cool. So let's take a look at our little note sheet here. Okay. So at the top, I have a basic little example. Okay? Absolute value inequalities is just like the equations, except we have greater than or less thans. Okay? And you're going to notice that our steps are very similar to the steps that we had with equations, because they are. Okay, so our example, we're going to write this right here. Our example is 3 absolute value of x plus 1 greater than 6. 3 absolute value of x plus 1 is greater than 6. Okay. So let's follow these steps. Step 1, isolate the absolute value, just like our warm-up, right? So to get this absolute value by itself, we would divide by 3. So divide by 3, that'll cancel out this 3. Divide by 3. So now I have absolute value of x plus 1 is greater than 6 divided by 3 is 2. Okay, now ask yourself, is this possible? Can absolute value be greater than 2? Well, it's distance, right? The only thing that distance can't be is what? Negative. Distance can't be negative. So as long as this isn't saying it's negative, we can work with that. Okay? So we can split this into our positive and negative paths. Okay? So all of that is the same. So our positive path just looks like x plus 1 is greater than 2. And on our negative path, it'll look like negative that. So negative x plus 1 is greater than 2. So notice when I do the negative path, I'm not changing anything about the symbol or the right side. The only thing that I'm doing is taking the insides, the guts of the absolute value, and throwing it inside of a negative sign. Okay? Okay, now we're going to solve each path separately. Oh, there's a little note here. Remember the sign flip when you divide or multiply by a negative. Okay, so that might happen here. So let's go up to our positive path. This one's always the easier one. It's less steps. All we have to do is subtract 1, right? I'll just write this below the line. So I have x is greater than 2 minus 1 is 1. Right? Okay. Now when I come over to do the negative path, we have to distribute our negative just inside the left side, right? That's it. So negative x, or if you want to put negative 1x, that's what I'll do. Negative 1x, and negative 1 times 1 is just minus 1. Okay. Now I want to solve, right? So I want to get rid of this minus 1. So we plus 1 to get rid of it. So we have negative 1x is greater than 2 plus 1, 3. Okay, but I'm not done yet because I don't have x by itself. I have to divide by negative 1. Okay, I'm dividing by a negative in an inequality. Here's where that note comes in, right? If I'm dividing by a negative in an inequality, I have to flip the direction of the symbol. This is key. Our answer is going to be totally wrong if we don't do that right. Okay? Okay, so now I have x. My symbol is not going to point that way anymore. It's going to be this, less than 3 divided by negative 1 is negative 3. Okay. Y'all good so far? Y'all get why we had to flip that sign? Because we had negative, we divided by negative. Okay, step 4, map the inequalities on a number line. So now I want to draw a picture of what this looks like. Because there's lots of numbers that are bigger than 1. And there's lots of numbers that are less than negative 3. So let's map it on a number line. And we can use this little key right here. This little note sheet is so helpful for many ways. Okay, so if I want to do x is greater than 1, so look here, greater than, open circle going to the right. So say I put 1 here. This would be open circle going to the right, because x is greater than 1. Okay, so I'm mapping that one first. Then I have this one right here. X is less than negative 3. So you don't have to build a number line and put all the right tick marks. You just have to make sure the numbers are in the right spot. Like negative 3 comes before the number 1 on a number line, right? So just pick a spot, call it negative 3. And that one says x is less than, so that's an open circle going to the left. Okay? So that's a picture of what our solution looks like. So on like my little example that I did with you before we started, it looks something a little bit like this one. Right? Okay. Step 5, write your solution set using either set builder or interval notation. Okay? So like I said, in notes, I'm going to give you both versions. If I choose set builder, that gets a curly brace. Okay? And then I have to figure out what's my variable. Most of the time it's x, right? So this would be the set of all x. That line means such that. And then I would just join these two inequalities here. I would say x is greater than 1 or x is less than negative 3. Okay? If I choose interval notation, which I'm going to guess most of you will eventually because it is kind of less to write. There's two intervals, right? I have two intervals, and whenever we have two intervals, we have to join them with the u, okay? So this first one begins in negative infinity, and it goes up to negative 3. Does negative 3 get a bracket or a parentheses? Right. If it's an open circle, open circles always get parentheses. Okay? And then we have another chunk, so I have to union that with the other chunk, 1, which also is an open circle, so it gets a parentheses, comma, and that arrow is pointing into positive infinity. Okay? So this is the solution number line, and then you could have this or that. This or that. Okay? All right. Just like yesterday, I want to do a couple more examples, but I'm going to put them in the notebook. Okay? And then I'll just use these steps to help me do it. Okay? When we're done here, I'll write you a pass. All right. So let's try this one, example 2. Absolute value of 2x plus 3 is less than or equal to 5. Okay. So let's follow our steps. Step 1, isolate the absolute value. I think did I highlight it yesterday? I don't remember. This needs to be the only sign, or the only thing on its own side of the inequality, okay? And it is, right? There's nothing else. It's not like this problem where we had to divide by 3 first. So we're good. We can proceed to the next step, which is split the equation between positive and negative paths. Okay. So we're going to have positive path and a negative path. Okay. So positive path, you keep everything the same. We're just dropping the absolute values because now we're doing what the absolute value means, right? And then over here, I would have negative, what's inside? 2x plus 3 is less than or equal to 5. Okay? So left side, we just subtract 3 and divide by 2, right? So 2x is less than or equal to 5 minus 3 is 2. Then we divide by 2. So x is less than or equal to 2 divided by 2 is 1. Okay, so we have that one. Now we're going to go over here, and we're going to do the negative one. So we have to distribute the negative on the inside of these parentheses. We're not doing that to the 5, though, right? Just what's inside the parentheses, because we only are making the stuff inside its negative self. So negative 2x. And then negative 1 times 3 is minus 3, is less than or equal to 5. Okay? So now we need to do what to both sides? Add 3. Because there's a minus 3 there, and the opposite would be to add. So now we have negative 2x is less than or equal to 5 plus 3 is 8. Now we divide by negative 2. Oh, I'm dividing by a negative. Don't forget, there's always going to be a sign flip somewhere in these. Okay? So I'm dividing by a negative. So now it's x I'm going to change the direction of that inequality. It'll now be greater than or equal to 8 divided by negative 2 is negative 4. Okay? Any questions how we got these two? We all good with why we flipped the symbol here? Because I divided by a negative. Okay, now, these are my inequalities. Now, I have to do the next step, which is map them on a number line, and I got to use this little key, okay? So I'm going to map these on a number line. All right? So what I would do is I would put the numbers on there first. So I got 1 and negative 4. And it doesn't matter. Just make sure your number line makes sense. Negative 4 has to come first, and then 1. Okay? Okay. If x is less than or equal to 1, that's a closed circle shaded inwards, right? Closed circle shaded, not inwards, I'm sorry, left. All right, so I'm going this way. And if x is greater than or equal to negative 4, that's a closed circle, and that's going to the right. So it's going to be the space in between. Every single one of these is either going to be the space in between, or it's going to be on the outsides. It's either going to be an innie or an outie. Okay? This one's an innie because they're on the inside. Okay? So now I just need to say my answer, and I can choose how I want to say it. Let's do interval first. If I want to say my answer in interval notation, there's only one interval. There's a start and a finish, right? It starts at 4, ends at, or I'm sorry, that's wrong. It starts at negative 4, and it ends at positive 1. And since they're both closed circles, they're both brackets. So negative 4, comma 1, bracket. Okay? If I want set notation, this one would be the set of all x such that, and x is in between, right? The shaded region is in between negative 4. So negative 4 is less than or equal to x is less than or equal to 1. I bet you're going to like one of these better than the other. That's great. You give me the one that you are most comfortable with. But just realize that sometimes you might have a multiple choice question, and the multiple choice might be in the other notation. So you don't have to be able to write both, you just have to be able to at least understand what they both mean. Okay? All right, I think we're going to stop there for this. Okay? Where's my mouse? Where's my mouse? All right, so you can go ahead and tape this into your notes.